Okay, it's time for my favorite type of synthesis. I am totally a West Coast Buchla kind of guy. We're doing FM. This is not FM in the Yamaha sense. That is actually technically phase modulation. It's using multiple oscillators and operators. This is two oscillator sine wave frequency modulation. Let's do it. So, we need to make a couple of adjustments here. First and foremost, what I'm going to do is I'm going to take this cycle down here. I'm going to delete that. I'm going to connect this directly to the ADSR envelope. Now, we're going to do a couple of changes. First and foremost, I'm going to get rid of that. That's cool, and we're going to duplicate that. With frequency modulation, what is happening is that we are going to take the frequency from our carrier and we're going to change that or modulate it by adding what is coming out of a second sine wave. That's why we're using the plus tilde, and that's going to go into here. So here in our modulator, we have a couple of different things to take a look at. We've got the frequency, and we have the depth. And why did I hit J? Now, the depth of modulation has some interesting properties we're going to look at in a second, but this is it right here. This is what we need if we want to modulate the frequency. So I've got a carrier. I'm just going to play A440. Frequency of the modulator is 1. Depth of the modulator is 1. Let's hear that. Yippee. Let's change that frequency. Let's try, how about 17? Nothing. 440. Okay, now I know something's definitely wrong. What if we change this depth of modulation to something? Oh, there we go. Hello. So, in fact, it is kind of the reverse. It's really this depth of modulation is functioning in a range of 0 to the sample rate divided by 2. It's a huge range, and that is being added to this frequency that's coming out of cycle. This is pulsing that up and down, and it's being used to multiply that. So you get a huge, huge, huge range of values that can then be added to the frequency going into this cycle. So now I've got 440 plus 305 times the cycle. So that's going plus 305 and plus negative 305. Well, what if we do larger values? And what if it's a quicker frequency? Let's try that 990. Oh, there we go. That's the fun stuff. All right, so at this point, what I've got is if I reduce the depth, you'll notice that the number of harmonics that are showing up in the spectrogram are lower. But if I increase it, we get more. If that frequency is lower, let's try, I don't know, I'm just throwing values in. Yes. If it's inharmonic, if it is not related to the frequency, we get some really interesting difference tones. So there's 261.5-ish hertz. That is the middle C, or a multiple thereof. C sounds pretty good. A does not. G sharp really does not. Yeah, so much fun. Doing this, you are typically using just sine waves. That is the classic way to do it. That is the Buchla way. That is how my actual oscillator, the Make Noise dual prismatic oscillator core, functions on my hardware synth. It doesn't have to be. Let's get crazy. So let's change this to a rectangle, and let's do, it doesn't matter, and let's do a duty cycle of 0.5, which we're going to modulate very, very quickly. Let's do a floating point, and we're going to give that a range of 0 to 1. Kind of cool. What about a triangle wave? I am liking that. But last but not least, because I have to, what about a sawtooth wave? Why does that not work? Well, because a sawtooth wave is not giving me negative values. Take a look at this. And why is it not giving me any values? Let's give that a frequency of 440. That should give me something. Okay, now it's giving me positive and negative values. Ha! Thought it was only not giving me the negatives. I was going to say it should be giving me both since it's anti-aliased, but there we go. Now, obviously, as you increase the depth up to, say, the Nyquist frequency, more metallic. If you're using really inharmonic tones, like, oh, I don't know, 3.1415, 9. And let's just get rid of that decimal place. Interesting. What happened? Well, we overshot our values. So at that point, we're getting way too high. We would need to take this down into a different range and then maybe increase that. But this tends to still work best with just cycles, just using sine waves. I don't know why that's suddenly dropping stuff there, but whatever. Anyway, yeah, that is frequency modulation in a nutshell. This one is going to be way too much fun for you to play with. I highly, highly, highly recommend it.